Okay, students, so in this video, we'll actually take data for the Zeeman experiment. So what we'll do is we'll start where we left off with the last video by just having an intensity profile across the Fabry-Pro interference pattern, as you can see here. But now what I'll do is I'll zoom in on just one of the peaks. And I'll just choose this one right here. Anyone's okay. And so that's just the maximum of the Fabry-Pro, as you can see it. And what we'll do now is, of course, this is about measuring angles at which beams leave the Fabry-Pro interferometer. So what I'll do is, this is the power of the software, I will click on just the very top of the peak. So I've identified that interference maximum of the Fabry-Pro. And the software is very smart. It'll just tell me the angle at which that's appearing. So it isn't the 35.2. It's this number over here, which is negative 0.979. That's alpha coming out of the Fabry-Pro in degrees. So minus 0.979 degrees is the angular pattern that this maxima falls at coming out of the Fabry-Pro. So now what we'll do in our next step is we'll start to increase the magnetic field to split this intensity coming out of the Fabry-Pro, and we'll track the angles of the split rings. So we're turning up the magnetic field, turn up even more. There's some splitting happening. We turn up even more, so maybe right about there. And so what we'll do now is we'll identify the angular pattern of each one of these split peaks, and that'll form our data. But before we go on, remember that the magnetic field that we found is given by this meter over here, which is the Gauss meter. So right now we're at 1,230 Gauss about, and so that's the magnetic field that's causing the splitting. So let me go and identify the peaks. There's one here at an angle of minus 0.920, and there's one here at an angle of minus 1.048. And you see the magnetic field value. So now we'll increase the magnetic field even more. And we'll just find these angles. So there's one there. And there's one here. So you're always looking in this side panel for the data point that has that little dotted box around it. And you can see the magnetic field value on the meter. So increasing the magnetic field more. We will identify the angle of this peak. And we'll identify the angle of this peak. Okay, so we'll increase the magnetic field more, and you can read the magnetic field value there, but we'll increase more now. And we'll identify the angle of this peak and the angle of that peak. And increasing the magnetic field still more. Up we go. We'll identify this peak and that peak. And we'll increase the magnetic field more, just a couple more. We'll find this peak and that peak. And if we turn the magnetic field down, once again, you can see both of these rings will merge back to that original ring, indicating no Zeeman effect is occurring. So there you go. See the rings just go back and merge again all by themselves. And you're back to where we started, at approximately zero field. So that's where your Zeeman data will come from. It's the B field versus the angle of where those maxima fall.